Okay, so in this video, we're going to talk about factoring special expressions, okay? There are two special expressions we're going to look at for today, one in this video and one in the video that will follow. So first, we're going to start with perfect square trinomials, and then we'll go over difference of squares, okay? So this is still when we're factoring quadratics or things of a quadratic nature, all right? So first thing we need to know, in both of these, we're talking about perfect squares. So perfect square trinomials, and this is a difference of perfect squares. So we need to know what perfect squares are. So when you square 1, you get 1. When you square 2, you get 4, and so on down the list. Okay, so there's the first 6 perfect squares there in red. So 1, 4, 9, 16, 25, and 36 are considered perfect squares because they're a number here, 6, multiplied by themselves, okay? So the next 6 perfect squares would be 49, 64, 81, 100, 121, and 144. So these 12 numbers in red here represent the first 12 perfect squares, okay? Now this list goes on forever, okay? But this is the first 12. You really should kind of have these memorized. And so on, okay? Now, these are for numeric perfect squares. For variable perfect squares, when you square x, you get x squared. When you square x squared, you get x to the 4th. When you square x cubed, you get x to the 6th. When you square x to the 4th, you get x to the 8th. When you square x to the 8th, you get x to the 16th. When you square x to the 20th, you get x to the 40th, okay? Now, obviously, I've skipped some in here. I skipped x to the 5th squared and x to the 6th squared and so on. But the one thing you need to notice is that each of these is considered a perfect square and they have an even number for an exponent, okay? So if you have a variable expression, if the exponent is even, then that's considered a perfect square, all right? So going backwards though, we can think of, well, 1 is a perfect square. The square root of 1 is 1. 4 is a perfect square. The square root of 4 is 2. And so on down the list, okay? When you're dealing with variable expressions, you've got an even exponent, okay? Using the laws of exponents, when you take the square root of x to the 6th, you're basically cutting that exponent in half. So the square root of x to the 6th is x to the 3rd. The square root of x to the 40th, again, take that exponent, cut it in half. The square root of x to the 40th is x to the 20th, okay? So what you're going to hear me say when you're factoring these perfect square trinomials and these difference of squares is that recognition is the key. So you need to recognize when you have either perfect square trinomials or difference of squares, okay? So first off, let's see what perfect square trinomials are going to look like. Well, let's see first off, what is x plus 5 to the 2nd power? Okay, well, we can break that down as x plus 5 times x plus 5. And when we multiply that out, we get x squared plus 5x plus 5x plus 25, okay? Well, notice I have 2 of these 5x terms in here. When I combine those, I get 10x, okay? So this is considered a perfect square trinomial because it is a binomial, okay, x plus 5 to the 2nd power, okay? So this is considered a perfect square trinomial, and when we factor it, our answer is going to look like, in this case, what we started with, okay? Same thing over here. We've got a binomial to the 2nd power. So if I break this down and do x minus 5 times x minus 5, okay, this is what I'm going to get. Notice I've got 2 of these negative 5x terms. When I combine those, I get negative 10x, okay? So this is also a perfect square trinomial because it is a binomial to the 2nd power that produces this, okay? So previously, we'd worked on squaring binomials. We'd worked on using the distributive property when necessary to multiply 2 binomials. Well, now we're working on factoring, so we're going to start with this trinomial, and we want to factor it back into its basic parts. And in this case, that would be x plus 5 to the 2nd power, okay? So we need to be able to recognize when we have a perfect square trinomial. If you don't, it doesn't mean you can't factor this. You're still going to use that AC method that you learned previously to factor this. But if you can recognize that you're dealing with a perfect square trinomial, then it just becomes easier to factor, okay? So, factoring perfect square trinomials. A trinomial is considered a perfect square if it can be factored into a binomial multiplied by itself. okay? Like this, a binomial multiplied by itself or a binomial squared. Same thing here. This is a perfect square trinomial because when we factor it, we would get x minus 5 quantity to the second power, okay? So, property here. If we've got a squared plus 2 times a times b, okay, and a would be the square root of this, b would be the square root of this, okay? If this pattern exists, like it does here, okay, then we know we've got a perfect square trinomial, and we can factor it as the square root of a plus the square root of b to the second power, okay? Or if the middle term is negative, like is the case here, okay, you're going to take the square root of the first term, x, the square root of the last term, 5, and you're going to separate it with the same sign for the middle term, which in this case would be negative, okay? But again, recognition is the key, okay? So let's look at number 1 here. First thing you want to ask yourself is the first term a perfect square? And it is. It's a variable with an even exponent. All variables to an even exponent are perfect squares, okay? So the square root of that, or it's x to the second power. We can rewrite that, okay? Is 49 a perfect square? Yes, it is. It's on our list above there. It's 7 times 7, okay? Then the last thing we want to look at is the middle term 2 times the square root of the first term times the square root of the last term? Well, 14x can be written as 2 times the square root of x squared x times the square root of 49, 7. Okay? So, this meets our criteria. First term is a perfect square. Last term is a perfect square. And the middle term is the product of 2 and the square roots of the first and the last term. Okay? So, because this meets our criteria as set forth here, that means we can factor this as x plus 7 to the second power, okay? Square root of the first, square root of the last, keep the sign in the middle, okay? And if I were to multiply x plus 7 to the second power, it would give me this trinomial right here, okay? All right, so again, recognition is the key. Let's look at this problem now. Question you need to ask yourself, is this a perfect square? Is this a perfect square? The answer to both of those questions is yes. Now, is the middle term 2 times the square root of x squared times the square root of 36? Okay, so x squared we can rewrite as x to the second power. 2 times x times 6, because 36 is has the square root of 6. Okay, so this matches our pattern up here that we were dealing with. Okay, if this were any number other than 12, it wouldn't meet the criteria we need here in the middle. Let's just say this were 13x, okay? I could still factor it if this were a 13x, but it just wouldn't be a perfect square trinomial, okay? But because it meets our property up here, we know we can factor this. So the square root of x squared is x, square root of 36 is 6, middle term is negative, so my answer is going to be x minus 6 to the second power, okay? All right, now pause the video here and try these last two, 4x squared plus 12x plus 9, and then 25x squared minus 90x plus 81, and then come back and check your work. Okay, 4x squared, it is a perfect square. The coefficient 4 is a perfect square. The variable x squared is a perfect square, so the square root of this would be 2x, okay? So 2x to the second power is a way of rewriting 4x squared, okay? Square root of 9 is 3. So what we need to see is, does this middle term, is it 2 times 2x times 3? And it is, okay? 2 times 2x times 3 gives me this 12x, okay? So it matches our criteria up here in the property. And then I know the square root of 9 is 3, okay? Now notice the first step that I've done in each of these problems, that needs to become a mental step very quickly, okay? I don't want you having to write this out every time, but for now and showing this in the video, it is necessary. So, square root of 4x squared was 2x, square root of 9 was 3, so my answer is 2x plus 3 to the second power. And again, this sign is positive because my middle term was positive, all right? Finally, 4. 25x squared, that is a perfect square. 5 times x would be the square root. 81 is a perfect square. The square root is 9. So the part we've got to check is, does the middle part match up? So again, 5x to the second power, okay? 2 times the square root of this, good. Times the square root of this, good. Now let's see what that equals. Negative 2 times 5x is negative 10x. Negative 10x times 9 is negative 90x. So that matches my middle term, okay? That means this is a perfect square trinomial, okay? So my answer is going to be this square root and this square root, and we're going to keep that sign from the middle. So the answer here is 5x minus 9 to the second power, okay? So again, main thing, you've got to recognize that this is a perfect square trinomial before you can use the pattern. If you don't, it doesn't mean you can't factor it. You can always use the AC method, trial and error, whatever method you're comfortable with, okay? But if you can recognize you're dealing with a perfect square trinomial, then factoring these becomes very easy.